Okay, so this week we're going to be focusing on division, negative exponents, and the zero power property, which we already discussed. The zero power, anything raised to the zero power is just 1. So here we go, laws of exponents division. Okay, so before I just throw rules at you, I'm just going to explain to you exactly why the rule exists. So let's take a look, right? X to the 5th means x times x, 3, 4, 5, divided by x to the 2nd power. And now, just anything divided by itself is 1, right? 3 divided by 3 is 1. 10 divided by 10 is 1. That's why we can just cancel stuff out, right? It doesn't just magically cancel. We can cancel it out. So this x cancels out this x. This x cancels out this x. So we're only left with these 3 x's here. And once we recondense that, you're going to be left with x to the 3rd as a final answer. Can anyone use their critical thinking skills? How do we take a 5 and a 2 and make a 3? By subtracting, right? So all we have to do is that. We just subtracted. But then we have a situation like this, right? Where the higher exponent, the 5, is in the denominator, and something different is going to happen here. And let's investigate. X to the 2nd power. X to the 5th. 1, 2, 3, 4, 5 of them. X to the 5th. So now, x divided by x is 1, so they technically cancel out. These cancel out. So you're left with 3 x's in the denominator. So technically, we have 3 x's in the denominator. But since these guys really were 1 when we cancel them out, we can sort of use 1 as a placeholder on top, because you can't have a fraction without both parts. So what you really need to take away is you're just subtracting exponents if they have like bases, meaning, you know, they're both x or they're both y or both a, whatever. But the final location, numerator, denominator, is wherever the exponent was higher in the first place. All right, so here we're going to just jump right in. 3 over negative 2 we can't really simplify that, but we can, you know, it makes the entire fraction negative, because a positive divided by a negative creates a negative result. So the entire fraction is negative. So you put your little negative out front. The 3 and the 2, nothing we can really work with. This n technically has like a 1 on it. So think, where is your new n going to go? Is it going to go in the numerator or the denominator? And it's going to go in the numerator because the original, the 4 on top, is bigger. So that's like where the leftover n's are going to end up. So it's going to go in the numerator. And 4 minus 1 is 3. So just to clean that up, we have negative 3n to the 3rd over 2. All right, next example. Let's take a look at our coefficients. Remember, you're not subtracting coefficients. You're treating them like regular numbers. So 2 over 4, we can simplify, right? It simplifies to a half. Okay, and then boom. So let's take a look at our r's. Should it end up in the numerator or the denominator? It's going to go to the denominator because that's where the original bigger exponent is. So that's where all the leftover r's are going to be after we cancel out and subtract. So 4 minus 1 is 3. And that's it. Your final answer. I'm just going to clean it up. 2r to the 3rd. All right. So first, let's deal with our coefficients. We've got -4 over -3. So let's think that one through. What do the signs mean for our entire fraction? Well, a negative divided by a negative is a positive, which makes our entire fraction positive. And 4 over 3 does not simplify. Now let's take a look at our x's. Where's it going to go? In the denominator, because 4 is bigger. That's where they're gonna end up. 4 minus 1 is 3. Ew. Whatever. Now, for those of you a little more like mathy, right? What if I did say, like I wasn't really focused on where it was going to go, right? 1 minus 4 would bring me to a -3. Keep that in mind. It's going to come up in another video. But keep that in mind. What happens if you have negative exponents? We're going to find out. Cool. So here we go with multivariable, right? We have more than one. So just like with the multiplication rules, you can't just like mush them together. They are separate entities. So let's think about our coefficients first. Negative divided by a negative is positive. And 2 divided by 2 is 1. So we could write 1 over 1 if we wanted to, but we would have to remove it later. So kind of like, what's the point? So I'm just not going to write anything at all. They cancel out. They're gone. So now let's deal with our M. M for Mary. M. All right? I'm going to end up with an M in the denominator. 2 minus 1 is 1. M to the first. But we don't really write ones. So it's just M in the denominator. Now we have dealt with our coefficients. We have dealt with our M's. Now we're going to deal with our N, which is the only one left. Nothing combinable there. So that would be how that one goes. All right. Coefficients. I got nothing but that 2 there. Nothing I can do with that. It just comes over. Now, if we're dealing with our A terms, you can look at it like, hey, man, they just cancel out. Boom, done. Or you can say, because like they're exactly the same, so of course they cancel out. Or you can say 1 minus 1 is 0. And we know anything to the 0 power is 1. So I could put a 1 if I wanted to somewhere, but it's kind of like just they're gone. Now we're dealing with our B terms. We know the leftover B's are going to land in the denominator. 2 minus 1 is 1. So we have B to the first power, but we're lazy. We don't write ones. So, but now you can't just have nothing in the numerator because it is a fraction. So we just sort of use that one as a placeholder that we sort of didn't write before, but we need to have something. So it's 1 over 2b. And I believe, yep, we're ready.